Welcome to Getting Started with Raspberry Pi Pico and MicroPython using Thonny. In this short video, I'll guide you through the getting started process and provide you with some hints and tips on using the Pico in the classroom. In this session, we will take a look at the Pico itself, why use Thonny as a development environment, setting up the Pico for first time use, writing our first program, and some hints and tips on classroom delivery. So what is the Raspberry Pi Pico? The Pico is a small microcontroller. Microcontrollers are used in embedded systems and are programmed to carry out single functions, such as a washing machine is programmed to do laundry. The Pico can be used for a wide variety of uses. It has 40 pins, 26 of which are general purpose input and output pins. These can be used for input and output devices such as buttons and sensors. So let's take a closer look at the options for the Pico. There are two main types of Pico: the original Raspberry Pi Pico, shown here on the left, and the Pico W, here on the right. The first thing you'll probably notice is the inclusion of this wireless module. And that's really essentially the main difference between the two. There is some other minor differences, such as the placement of the onboard LED. Although they're physically in the same place, the way that they're connected to the Pico internally is slightly different. But for the best part, they are the same. Deciding on which variety to get will really come down to budget and potential use. The Pico itself is slightly cheaper. The headed version, so with pre-soldered pins as shown here, is around £4, whereas the W, again with headed soldered pins as shown here, is around the £6.50 mark. If you plan to buy in bulk, you can get some really good deals. 50 Pico W's on eBay is around the same price as 50 Picos on Amazon, or even with a local supplier. This unit doesn't require the use of wireless capabilities. However, if you plan to use Picos in the future for other things such as building robots or creating wireless servers, and your budget allows, I would always recommend that you go for the W. Likewise, there are cheaper options for buying Picos without the soldered headers. It's a really tricky process, particularly for beginners, solderers. And so therefore, I would always recommend that you purchase Picos with the headers already in place. Okay, so now you are familiar with the two varieties. Let's take a look at the pin-out diagram provided for the Raspberry Pi Pico. This is the original Pico. As I've already mentioned, there is very little difference between the two other than the wireless capabilities and of this pin here, which I'll come to in a moment. So the first thing that you will need to notice, and the first thing that you will need to find in order to use your Raspberry Pi Pico, is this boot select button. This boot select button allows us, when plugging in the Raspberry Pi Pico, to put it into boot mode, which allows us to install the firmware. The Raspberry Pi Pico can work with multiple languages. In this video, we are only going to look at Thorny, and we are going to look at MicroPython, but there's also the option to program the Pico in C and in Circuit Python as well. Using this boot select allows us to change the language that we use. So here is an onboard LED. It's a really nice little feature for getting started. It allows us to do something physical straight away. If you're using the original variant, as I am here, then the LED is attached to pin 25. You can see that in the pin diagram here. If, however, you're using the wireless version, this is no longer attached to pin 25. It's actually directly attached to the chip, and it's referred to simply by the name LED as a string value, all uppercase. So depending on the variety that you are using, if I refer to pin 25 on the Pico W, the pin 25 would be substituted for the string value LED. So on close inspection, and this is something that can prove a little bit challenging to students in the early days, because there is 40 physical pins on the Pico. These are each side, and hopefully you've got the variety that is attached to headers. The pins start from pin 1 and go up to pin 40. These are the physical pin references. However, as there is only 26 GPIO, general purpose, input and output pins, then the GPIO numbers don't correlate to the physical pin numbers. So as I say, this can seem quite confusing at the beginning, and it's worth really taking time as you're working through the code, referring students back to this diagram. You'll also notice that there is several ground pins. One of the really nice things about the Raspberry Pi Pico is that if you look at these ground pins, you can see a physical difference. The pin outline is square, whereas the other pin outlines are circle. So that makes it really easy to identify these ground pins and use those as a reference for counting the pins backwards or forwards up from these pins. For example, in this video, we will look at the ground pin, the third from the top, from the right, and this fifth pin. And using this as a reference, the students know they can check that by counting 2 down from the third pin. Okay, so let's have a look. So we use these physical pins to create circuits. And to create circuits, we do need to use the ground pins, and we do need to use these voltage pins here, specifically in this course on this fifth pin down, which is the 3-volt power. So, that's about it for the pinout diagram. So there is a separate handout available for teachers that take you through all of these different protocols. So as well as being used as general purpose, so GPIO pins, each one of these pins also has specific protocols attached that allow us to do very specific things. So for example, if we look here, These are analog digital converter pins, which allow us to use analog devices as both input and output. Each of these are described in the separate teacher handout, but it's not something that we need to worry about today. And as we come across the various tools, we do cover these individual relevant protocols in more detail. So as I already mentioned, we are going to be using MicroPython to program the Pico. And for the duration of this course, we are going to be using the Thonny integrated development environment. There is other options. This is definitely the preferred mode. So what is Thonny and why are we using it? Thonny is an integrated development environment that allows serial connection via the USB port to external hardware, such as the Raspberry Pi Pico. This means that once it's set up, code can be executed directly onto the Pico using the USB. This makes testing and debugging so much simpler. As a development environment, it's got great range of debugging tools such as variable tracking and syntax error highlighting. This is great for beginners and advanced programmers alike. And best of all, the interface is really clean and easy to follow. It has a great package installer that simplifies the installation of external packages that we will be using later on. It's free. It can be downloaded direct from the Thonny website. There's easy to follow installation guides if required. So in this video, it's assumed that you have already got Thonny installed. And in the next step, we'll simply move on to the setup of Thonny. If you need to install Thonny, I would suggest you pause the video now and come back when you're ready. Okay, so if you have Thonny installed, you can go ahead and open it, and you should see something like the window below. The built-in shell is a really great function. And Thonny also has a built-in plotter that we'll make use of later on. But setting up the Pico is really straightforward. So if this is the first time you're using the Pico, the first thing that you need to do is to plug the Pico in using the USB port, holding down the boot select button that I mentioned earlier. This will allow you to install the required firmware. If it's your first time using the Pico, you'll need to install the firmware. Thonny can handle this process for us. To begin, hold down the boot select button when plugging in the Pico. Then using the Configure Thonny menu, click on Install MicroPython. In the pop-up menu, choose the correct variant, either Pico or Pico W, and click on the Install button. You can see that Pico installation, the MicroPython firmware installation to the Pico, is happening in the background. Once it's completed, you simply click on Done. As a point, configuring the interpreter is always done at this bottom left hand corner. We'll be coming back to that a little bit later. Okay, now you've installed the MicroPython firmware, we need to set up the interpreter. It's a really straightforward activity, but it's one that students may need to do at the start of every lesson, depending on how your system defaults. So it's a really good habit to remind students to do this each lesson. So we go back to the configure menu, and this time we're simply configuring the interpreter from the Python 3 standard to the Raspberry Pi Pico. Try to auto detect, allows the students to change ports, so the USB ports, and it will automatically detect the port that the Pico is on. And that's it. It's really straightforward. It's just a case of remembering to do this. If when you are programming, you come across the pin error where it says unable to import from the machine library pin, it's usually because you have not configured the interpreter, and the machine library is not part of the standard Python library, only of the MicroPython. Okay, so now you have installed the firmware for MicroPython, let's take a look at some MicroPython code written for the Pico. Pause the video and see if you can predict what will happen when this code is executed. You'll probably be able to predict that the onboard LED will flash, and hopefully you'll be able to recognise other aspects of the code, such as library imports and iteration. Machine is MicroPython's library for interaction with hardware. MicroPython is a scaled down version of the full Python. As with any library, you can add the whole of the library or simply import modules and objects from it. Most embedded systems continually monitor hardware for changes in states. Using an indefinite iteration allows for this. Digital pins have two possible values, only 0 and 1. The method on line 7 sets the value to 1, turning on the LED. The short sleep allows us to see the change in state before the method is called to return the pin to its off state. Because we're using an indefinite loop, we need to add a second sleep to allow us to visually see the second change in state. Let's have a go at coding this together. Okay, so let's have a go at coding this together to get the Pico blinking. So I'm going to start by importing the pin object from the machine library. Note how I use uppercase P, or it uses uppercase P. And then we're importing time, or from time, we're importing sleep. It's important to note that MicroPython has its own version of time, U-time. So you may come across this on tutorials. Thonny actually defaults time to U-time in the background, which just makes things a little bit easier for students who may already be aware of time and sleep. Okay, so now I'm creating an object variable and with the ID LED, and I'm assigning that to the pin object with the values 25, which is the physical pin that the LED is attached to, and I'm assigning it as a output pin. I'm now calling on the LED object and the method set value to set it to a 1, and as I already mentioned, using a slight delay so that we can see that change in state, and then go to reset the value back to 0, and again add another short pause. You might notice here I forgot to include my iteration, so this only runs once, but it does in fact work. So I'm just going to add my iteration here and indent my code so that I can now run the Pico. As you can see here, I have the flashing, blinking LED. Okay, just to finish off this session, we're now going to have a look at another method, a more efficient method in terms of coding to flash on this LED that the students will work through using the toggle method. So using the toggle method, I'm able to automatically change the LED from 1 to 0 and from 0 to 1. The toggle method reads the value and then changes it appropriately. And fixing typos there, and it now works. Okay, so that's it for this session in terms of coding. Okay, so just a couple of hints and tips before I let you go and hopefully continue to experiment with your Pico. I've been using the Pico for a number of years now. I've built it up over time, and I do many exercises over the GCSE and in Year 9. And one of the things that I really find useful is over teaching the syntax. Before I let students get hands-on, we go through the syntax together. I do use the prim model, so students are given a copy of the code or the starter code, which they predict, and then we go through it line by line. I have students annotate for things like uppercase characters, colons, etc., depending on their prior knowledge, because I find that that is where most of the errors are present in terms of the code. Where possible, when you get onto creating live circuits, that's not really applicable from today's session, but pre-set up circuits as well as providing handouts. Some students find it really easy to follow paper-based circuit handouts. Others prefer to have that physical model. And having a physical model also gives you a backup that if there is any problems, you can swap out quickly a student's circuit for one that you have pre-tested. And it just saves a bit of time in the classroom trying to troubleshoot. One of the things that I find is really useful is to group students into small teams of similar ability, and then they work together as a team to solve the problems, to get each other's code working. I give out a lot of stickers and rewards and spot prizes to students that have done particularly well as working together, and not necessarily always getting through all the activities, but developing that teamwork to get things working. I have tried in the past sort of having a team leader on the teams, but I find that they just end up rinsing and repeating the problem solving process rather than progressing their own development. So like for like works really well in my opinion. And then lastly, don't teach it till you've tried it yourself. I know there's never enough time in education as a classroom teacher, but going through the process, you'll understand some of the um, feelings that the students might have, some of the errors that they will come across, and it really will make you much better prepared for the lessons. Okay, I hope that was a really useful whistle stop guide to getting started in MicroPython and the Pico. And I look forward to sharing some further insights at a later date.